Okay, so this is how I did number 8. So we were given, here, let me change this actually. It's way too big. So we were given y equals natural log of 2x times the square root of x squared plus 3 all over sine of x. And we have to find dy dx, or how I like to call it, y prime. They're the same thing really. So let's go and find it. So before I even get started with trying to find the log, because there's two ways you could go at this, and the first way is the way that I first tried doing it when I first saw this problem, which is doing the quotient rule. So then this would be f and this would be g, but that takes way too long and it's way too complicated. So there's an easier way to do this. So before you even start taking any derivatives, you can rewrite this as y equals, so you have two of these. So a property of the logs is if they're dividing, you could minus them. So then you could do the natural log of the top, which is 2x multiplied by the square root of x squared plus 3, and then minus the natural log of the bottom, which is sine of x. You could do it once more here because there is another product, not another product, but another rule where if these are multiplying here, you can add them. So then you can rewrite this once again. It's natural log of 2x plus the natural log of square root of x squared plus 3, and then minus the natural log of sine x, like that. And then from here, what I would do first is rewrite this thing so it looks like this, because it's a bit easier to see. So natural log of 2x plus the natural log of x squared plus 3 to the power of 1 over 2, because that is the same thing as the square root. So then the natural log minus natural log of sine x. So now another property of these natural logs is that you can move this over here. So then you can have y equals the natural log of 2x plus 1 over 2 natural log of x squared plus 3 minus the natural log of sine x. Okay, now we could actually start taking derivatives. So the first thing I would do is remember this, the property that goes somewhere like, I don't know, d over dx of natural log u is equivalent to u prime over u. So just remember that and do them to all of these. So y prime, we have natural log of 2x. So 2x, the derivative of 2x should be 2. And then over the normal one, which is 2x. So then these cancel, and you have 1 over x here. So that's what would go here. So you have 1 over x plus 1 over 2 multiplied by, now let's do it again. So here you have x squared plus 3. So then that's a 2x, and then the 3 becomes a 0 over the original argument, which was x squared plus 3. So then just place that here. And then minus, so sine x we have here. So the derivative of cosine is cosine x over sine x, right? The original one. And what I did is that, well, this equals cotangent of x. It's the same thing. Those are, properties, or what are they called exactly? Identities. So you could just name that cotangent x right now. Although he didn't name it, but it's the same thing really. You could just use this one if you want. So let me remove these, make some space. Okay, so now out of these, you can see that we could actually cross out these before we do anything. Y prime equals 1 over x plus, that's just 1, so we have an x on top, over x squared plus 3 minus cotangent x. And I'm pretty sure that is actually the answer to it all. That's the derivative. There's another option, which again was if you use the quotient rule, but I am not going to do that because this takes way too long. So that's that. Again, if you want to not write cotangent x and just write cosine x over sin x, that's fine. That's how he wrote it, but I'm going to just do that. But yeah, that should be it. I'm pretty sure. Let me make sure I'm not tripping out and check. Yeah, that's the answer. So hopefully you understood that.